view of the heart. The first one was what we call the hexaxial system. The hexaxial system is where we take a coronal cut of the heart. We take a coronal cut of the heart, so go back and remember your planes. If you don't remember your planes, go back to your A&P class and say, I need to remember my planes. So coronal cut of the heart. So we are looking at, where did you go?
Oh, I put it back.
No, no. So we are taking pictures of the heart in this plane. Good? Our cameras are set around the heart this way, looking towards the plane, or towards the camera this way. Towards the heart this way. Does that make sense? Okay. So that's our hexaxial system. We have 6 cameras in that plane. We have 6 cameras in that plane. We call them leads 1, 2, 3, AVR, AVL, and AVF. We set those cameras because of the equilateral triangle that it is, that I'll show you in a minute. We set those cameras 30 degrees apart on the 360-degree circle. So we set them equidistant apart. We take the circle and we cut it into 6 halves. You understand what I mean by 6 halves?
6 pieces about 5. Whatever.
So this cuts it in half, that cuts it in half. That cuts it in half. Yeah, how many pieces about 5? That we cut it into. Okay? What's those pieces?
It's actually 12.
Okay. So the hexaxial system creates those six versions of it. Okay? We also sometimes refer to them as the vertical leads because it's in that vertical plane. The coronal plane is the vertical plane. We have 4 wires on the person. We have 4 wires, and from those 4 wires, we get 6 leads. From our 4 wires, we get 6 cameras. I'll show you how we do that in just a minute. The cameras are always sitting on the positive electrode and are always looking at the negative electrode, always. So as long as we always know where the positive electrode is and the negative electrode is, we know what that camera is supposed to be looking at, okay? And it's done in this way. So Einthoven created, all Einthoven knew was he knew that in order to look at electricity, you need a positive pole, and a negative pole, and a ground. You needed those 3 things. If you could ground things out and then send an electrical current through 2 poles, a negative and a positive, you could see a direction that wave is going. Does that make sense? And that's all he did. That's all he knew. He knew enough about anatomy to know that he needed to stick the wires on the right arm, the left arm, and the left leg. And if we did that, based on the flow of electricity through the heart, we would create an equilateral triangle around the heart, or through the heart. I'll explain in a minute. So he created this triangle that became known as Einthoven's triangle. Lead one is where we put the negative on the right arm, the positive on the left arm, and the ground on the leg. Okay? It's called lead 1. You might ask, well, why do we always look in lead 2? Why didn't we name lead 2 lead 1? Well, because Einthoven did this one first.
Yeah.
And so he named it 1. And it's not a big deal. We look in lead 2 because it was the second one he did. It just happened to give us the best view. Don't get hung up on it. Right? So our negative is on the right. Our positive is on the left. So where's my camera?
Right.
On the left.
It's on the left. Where's it looking?
To the right.
Towards the right. And my leg is the ground. That's what he did for this first lead. Okay? For his second lead, he kept the negative on the right, and he shifted. He put the positive on the left leg, and he stuck the ground up here on the left arm. So now where's my camera? On the left leg, where's it looking?
To the right.
On the bottom up.
On the right arm. And so we got this view of the heart. And then for lead 3, what he did was he put the negative on the left arm, the positive on the left leg, and he made the right arm the ground. And that gave us what view?
Lead 3.
And he gave us this view of lead 3. Now, the confusing part, and the part that I'm not going to kill you on, we're not going to deal with it, was that from the body standpoint,
Dude,
yeah, it's some weird guy.
it's Mons.
There we go.
Jack.
Yeah. From the body standpoint, our actual wires are going here, here, and here. Those are the placement of our actual wires. And from the flow of electricity through our body, it still translates as what's going on in the heart. That's a much larger, more advanced A&P session that we can do some other day, not related to paramedic. Okay? That gives us the best view when we put the wires in those locations. What that creates, based on the anatomy of the heart, where the heart is actually located, is an equilateral triangle. Y'all know what an equilateral triangle is, right? All sides are equal. An equilateral triangle with the point at the bottom. So this is then illustrated like this, and what it practically does to the heart is it puts the heart, if this is my heart right here, is it puts the triangle, it takes those equilateral sides and intersects them. So this is actually what my triangle is doing.
Hold up.
These are moved until they have an intersecting point. So therefore,
Wait, what?
when we say that this is lead 1 with the negative, positive, and ground right here, what we're actually saying is it's taking this view of the heart right here with the camera right here. Through the center of the heart. My lead 2, with my negative still over here, but putting the positive down here and the ground up here for my lead 2. Oops, sorry. My lead 2, if I can put it in the right place, right? With my lead 2 is actually taking this picture of the heart. That's lead 2. This is lead 1. And my lead 3, which is putting the negative here, positive here, and the ground up here, gives me this view of the heart.
When you did we were all standing up there and you did your camera view angle, so it's a little bit of backtrack, is that camera view an inline view, or is it more of a lead view of the heart?
It's an inline view. It's an inline view. It's not wedge shaped. The negative pulls it in an inline view with a narrow window. So my camera is always sitting on the positive, and it's always looking at the negative. And we're looking at what happens in between. Make sense? Questions on that so far? Okay, so that's what Einthoven did. That's what Einthoven did. And if we look at
That's how we end it, not with a period.
if we look at that unit, that's exactly what it does. So this unit is a more
Just a
basic
tool.
life, it's one of the first life Pack 12s that came out. And that's exactly what it does. It's a 3-lead unit. The only difference is that the machine, Medtronics, was able to come up with a way that instead of having to remove the wires and physically rotate them around the body, the machine itself figured out how to make the wire that is traveling to that particular leg have multi-uses. There's multiple wires inside the cable that's going to that leg. Some of those wires can be positive, some of those wires can be negative, and some of those wires can be a ground. And so this machine does that exact thing. When you want to see lead 1, then it puts the positive here, the negative here, and the ground on the leg. If you want to see lead 2, then it puts the positive there, the negative here, and it puts the ground up here, and it automatically makes that shift. And Medtronics was smart enough to figure out an algorithm that would allow all of those wires to work simultaneously so that you can actually see all 3 of those at the same time.
It's pretty cool.
It is pretty cool, which is why you pay thousands of dollars for it. But, whereas when this first came out on the market, it was give or take about $55,000, now this is a great paperweight. You can pick these up, I don't know, at Goodwill for $10, give or take.
Wow.
You can have a lot of fun. You could go defibrillate squirrels or whatever you want to do.
Frogs.
Whatever you want to do.
Turkey's a lot.
Because we went one step further and we went, wow, interesting. Well, we've got 4 appendages. We have a situation where and it didn't really start out as necessarily being, hey, what can we do with this other appendage? It was more of a, well, we have this technology we have to constantly be putting into these wires to make them shift from positive, negative, and ground. But why? Why can't we just get a universal ground? That way we're not having to make a ground wire be connected to a polarized wire. So let's just make one wire that's grounded. So they did. They said, let's add a 4th wire to the mix, let's pop it on the right leg, and let's just ground out the right leg. Then what we had was we had a 4-wire, 3-lead machine. It had a ground, and then it just shifted. So if I was looking at lead 1, here's still my positive, here's still my negative. My right leg is the universal ground, and my left leg's out of the mix. It just wasn't being used. Then if I wanted to see lead 2, it activated the left leg for the positive, kept my right as the negative, my ground was still universally the right leg, and it just left out my left arm, and that wire wasn't being used. So in a 3-lead, 4-wire machine, 1 wire was just not being used at any given time. But it improved the performance of the machine because you had a universal ground. You were able to take the ground away from the mix of the other ones, which means you could use better wiring, better technology of the material for the ground and get a better ground. And a better ground resulted in a better picture. Good? But then, somebody had a great idea. Well, why the hell don't we use this other wire that's not being used? Let's see if we can find a way to use it. So what they did is they went, only one of the poles has to be set, and that's the positive, because that's our camera. We can't have a camera that's moving around. We have to have a camera that's looking in one spot. But the negatives can move around. We don't care about the negatives. The negatives just dictate where the camera looks. That's all. It doesn't dictate what the camera sees, but it dictates where it looks. So, what happens if we say, let's leave this as a positive. Let's take our left foot and leave it as the positive. And right now, we have one of 2 options if the foot is the positive, if this one's the positive. We could look this way, or we could look this way. One of these wires is activated, and the other is not. Here's lead 2. Here's lead 3. One of these wires is activated, one is not. And that tells me where my camera's going to look. My camera's here, and it's either going to look this way, or it's going to look this way. based on where my negative is, right? What happens if we just activate both those wires?
Both negative.
Looking up.
Why not? Why not just activate both of these wires? And if we were to activate both of these wires, then my camera, being magnetized towards the negative, would be magnetized towards this one and towards this one. And if we make them the same value, then the camera would be magnetized towards the center of those two. Does that make sense? And so we basically made a pseudo negative electrode right there by magnetizing both, by making both those negative polarities activated at the same time. But things are a little bit weird, because let's just say, don't write these numbers down, don't even think of these numbers, because I'm just giving them as proportions, okay? Let's say that this is 20 positive looking at 20 negative. That make sense? Just pretend. The camera is a 20 positive value looking at a 20 negative value. And that gives me a picture. If I have a 20 positive camera that is being pulled to a 20 negative camera this way and a 20 negative camera this way, it's going to be pulled to the middle, but this charge, anyone know what that charge will end up being?
40 or 10?
30.
10.
This charge is half of this, is half as much as either of its two parent charges. It's half as much charge as either of these two parent charges. Because it's half as much as either of the parent charges, this middle one, this picture cannot be compared to, say, the lead 2 camera, which was a 20 on 20, or the 3 camera, which was a 20 on 20, or the 1 camera, which was a 20 on 20. So we couldn't compare. The amplitudes would be different and not proportional. So we couldn't compare them.
Does that mean you had to write the algorithm, the ability for a camera to put it in one form versus 2 in a separate form to make sure that
We came up with something easier.
You just amplitude it by the, yeah.
The two.
Let's just repolarize this to 40 and repolarize this one to 40 and make this one a pseudo 20.
Yeah, but doesn't that
Done.
mean that if your 20 is looking directly at the 40, the amplitude's gonna be off?
Yes.
When you're
Pick
trying to
that
compare
lead.
the two?
So
But then they
it only
change it
does
back
it when
to
you're
20
looking at that one lead.
That's what I'm saying, those leads have the ability of being
Yeah.
modified on the fly.
Correct.
That's why it's augmented.
Yeah. So what we did was we augmented the voltage and we put the camera on the foot, AVF.
We
Whoa.
are right.
That's amazing. And if we put our positive right there, then we will augment the voltage of this one and this one, and we will put our camera on the left. And if we put our camera here, which is the only other place the camera can really go, okay,
Figure.
and we augment this one, and we augment this one, then we have an augmented voltage with the camera on the right. And that's where you get those gains. Make sense?
You get 30 degrees in all directions.
And and because we've now split it here, and we've split it there, and we split it there, we now have we have 2 equilateral triangles stuck on top of each other, right? So now we see this view, which is AVF, yeah? We see this view, which is AVL. We see this view, which is AVR. We have now used 6 cuts of the pie. We've done 6 cuts in the pie, right? Which makes 12 pieces of pie. And if you have 12 equal pieces of pie in a 360-degree circle, each one of them is 30 degrees off, right? this is 90 degrees, right? 30 plus 30 plus 30. And we have now cut our heart equally into 30-degree increments on the hexaxial system. 4 wires, 6 pictures of the heart.
So over there, it shows that lead 2 is like on the left side.
No, it's
Sorry.
just because of the graphic that's being drawn here.
Okay.
What do you mean? So
I'm
you
just
mean on the left side of the heart?
Yeah,
The
so
right side
I'm
of the heart,
confused
actually?
how like 1, 2, and 3 are all totally different angles, but then over there they're kind of looking the same direction-ish.
Because lead 2 is looking from, on the graph on the left, lead 2 is looking from bottom right to top left. And if you took the triangles and took it away from the triangle view,
Oh,
And
yeah,
pushed it
okay,
towards the
yeah,
center.
yeah, okay, that makes sense. Yeah, I got it,
I'm
I
just
see.
taking this angle.
Yeah, and just
shove it
moving
into
it
the middle.
over, okay, cool.
that way all
Yeah.
3 of your straight lines now become a cross in the middle.
Correct. That's correct. So from a practical sense and a technological sense, this is what we're actually doing when we put our electrodes in these positions.
Okay.
That's what we see of the heart. Yes, ma'am.
So for the quick six,
The whole general
do
speaking.
those happen
Control movement.
in the same, can you augment in real time with the normal, unaugmented leads?
Yes, you can.
Okay, cool.
So the technology in the machine has made it so that we have wires in a cable that can both be augmented and not augmented at the same time,
Yeah,
which is the thousands of dollars that you're paying for.
yeah, I don't need to get that science, that's cool, I just wanna know.
But yes, you can, which is exactly why we can see those all at the same time.
Yeah, so when it's looking at that augmented lead for a specific beat, that is the same.
Yes, that is correct. Yep, that's right. And so ideally, in an ideal world, you would do a couple of things. In a complete ideal world, you would put the electrodes on wrists and ankles. If we were really doing it well, we would clean their skin. Then you would take a little bit of sandpaper and you would sandpaper off their epidermis. Then you would alcohol the area to clean it all off after that, and then you'd put the electrode there. That would be the research grade quality EKG that you'd be looking for, that wouldn't have any weird artifact or anything in it. We then modify that as necessary. So for example, it's oftentimes inconvenient in an ambulance to have wires hanging on people's wrists and ankles. So we move it up to shoulders and trunk in such a way, and hips, because it's easier for us with lack of movement. It is a less clear picture, but it is an adequate picture that shows us the biggest things that we need to see. So it's okay. We do need to know, though, that as we do that, we will get a less clear picture. And in some patients, with the right level of impedance and such, sometimes we can't get a clear picture at all, and we do need to move them back out.
You mean bariatric?
In some bariatric patients, it can be very difficult to get those pictures.
An
But we have
EKG with
to-
a trunk lead.
And so we might move it out. Yep. So we might, just because it's a very unclear picture that we see in that case. But the more we can get rid of the epidermis, the cleaner that we can make the skin, those are all better things that we can do to get a clearer picture. What we do know is that we need about a 10 centimeter distance from the heart to get any picture. So we need to be about 10 centimeters off the heart in whatever direction we're going to really get the right kind of a picture, which this does meet that criteria, even if it's not quite as clear as what we would do if we moved it down to wrists and
I'm
ankles.
assuming you're gonna explain why the 10 centimeters away from the heart does not meet the criteria for B1 or
Yeah, be the-
We're working on a
So
different
we'll
plane.
deal with those in just a little bit,
2. As I said,
because that's a different algorithm.
Is that
Different
because
plane, right?
If the cameras are too close, then it's like a real camera, like it would be
Yeah, it just gets blurry. It just doesn't get, it's not a clean shot.
The angle's different.
Questions on that? Okay, before you go, here we go. Then we have the precordial system. The precordial system takes the other plane. We're now looking at the transverse plane. So in my heart, I am now looking at it this direction. So my leads are here, all going inside. Okay? But there is a slight difference in how we deal with these leads. In these leads, we simply can't put any more electrodes on our patients. I mean, we can't just keep loading them up with stickers. We can't. And still be okay with the patient. One, we get overloaded on the patient. Two, the locations of where we'd have to put all those things is disruptive. It's hard to do. So instead, what we do is we take these 6 electrodes and place them around the heart. In this case, we're placing them in 20-degree increments, not 30-degree increments. So if we were to continue all the way around, they would cut this pie in 20-degree increments rather than 30, all the way around. Okay, and sometimes we do go around at least to the mid-spine. So in which case we go all the way to a 15 lead. But in this range, what we're doing is something slightly different, and that is we are taking these leads, and as we plug them all on, the machine goes through an algorithm that calculates where the center of the heart would be. It calculates the center of the heart. And it superimposes a negative charge at that location. And it's called Wilson's terminal. So the machine does Wilson's terminal, where it calculates what the center of the heart should be based on what it's reading about impedance, what it's reading about the hexaxial system, wires that it gets. It takes all that information in and goes through an algorithm that calculates a negative spot, which is right there. And all of these cameras are looking to that spot. So these are all the positives, and they're all looking back at that spot. Does that make sense? So you get cameras that are coming around this way. In this picture, it's looking like this. It's looking like this, right? So I'm looking at it this way on all of those cameras, with the camera being pointed towards the center. Good? Now, there are some goods and bads about that. For example, if you look at V6, V6 is right here looking that direction of the heart. What other lead does that?
Lead 1.
Lead 1 does that. So lead 1 and V6 look at almost the exact same thing. But what's the difference between those two leads?
The target
Yes. Where's the target of lead 1?
is on the far side.
On the far side of the heart. Where's the target for V6?
The
Right in the middle of
The
the
center of the heart. So you will see some differences in those two leads based on the fact that lead 1 has a different target that it's going towards compared to V6. So you will see a ton of similarity between those two leads, but you will also see some subtle differences between those two leads. Because lead 1 sees a little bit more than what V6 has the ability to see because of where that negative electrode is. Good? So lead 1 has the ability to see some stuff that's happening to the right ventricle that V6 can't see. And so you'll see some subtle differences. What questions?
So basically, all of the leads, V1 through V6, don't necessarily look at the posterior of the heart?
No,
No, that's not right.
no, they really don't.
Because they stop at the center.
Most of them stop in the center. Now, that being said,
The only thing
that
that
doesn't
stops
mean that
is
electrical activity that deals in the posterior of the heart doesn't show up to some degree there, because you are talking about a very small area, and you are talking about something that we can't rule out. So you do see some posterior stuff with some of these leads on the front, and I'll explain that when we get to those leads.
So if you're suspecting something more posterior, that's when you're gonna start running.
Then you would do a 15 lead.
Or if you're noticing something that's a little more right-sided.
Then you do a right-sided one. That's right. That's exactly right. If we suspect a right-sided MI, then we'll often do a right-sided 12 lead, or we'll do a few of the leads on the right side to confirm them. And a posterior side, that is in fact what they will do. They'll continue the leads all the way around to do a good 15 lead. We don't often do that in the field because we can make some pretty good guesses on what's going on in the posterior, but they would continue that around in cardiology. Questions? Yep.
What can V6 see that you want to see, other than the center?
It really can't, other than it's a different camera looking at the same thing, so you might see something clearer, or you might see some translation of what's going on with that plane from before, or what's going on in the posterior just a little bit. That'll be one that's a harder time seeing. But you'll find a lot of the things that we're gonna look at, we'll look at leads 1 and V6 together. Good? A break, a long break. Some of you take a break for the rest of the day.